So in this demonstration, we will be talking about Python exception handling. So what is an exception? The exception is a term which refers to errors which are caused during the runtime of the program. Right? So during the program running time, some abnormal situation may arise. See the example. I can give an example. The divide by zero error. For example, I am giving numerator and denominator, and by mistake, denominator becomes zero. So instead of non-zero, it becomes zero. So when you divide a number by zero, naturally what happens is you will get the answer as infinity. So the infinity cannot be stored in any variable. So that will cause a runtime error. So this is called an exception. The exception is has a very similar meaning in terms with our real life also. Exception is some abnormal situation. That is the same meaning is applied in Python also. Right? So now this is one the example which I told you was one, where the denominator can be zero. The other thing is when I try to give an input through a Python program. Now I want to have a number to be inputted. So the user, instead of typing a number, because I am typecasting whatever input he sends in, the user sends in, I am using typecasting using int. So while typecasting, instead of entering something in number format, the user enters in string format. For example, you should have entered 45, which comes through input statement, input function. And of course, it is in a string format. It should be typecasted into int again. But while instead of typing 45, he types ABCD. So ABCD cannot be typecasted into integer. So here we will come across value error. So value error means the value cannot be converted into integer because ABC cannot be converted into integer. Okay, now this is called an abnormal situation or error. Now, instead of the program to have a graceful exit, normally if you don't have a try catch kind of scenario, we will have a disgraceful exit. That means what? The program will terminate in between. Okay, so when the program terminates, there are so many things. The files which we opened may not be closed properly. Okay, or the memory which was occupied by the program will not be released properly. So this is called disgraceful exit. So nobody should have a disgraceful exit. Okay, including a program. A program should have a graceful exit. If the program is not able to generate the output, the program should gracefully exit the exit. Okay, graceful exit is what we call it as a Python exception handling. But of course, instead of exiting, we can give one more opportunity for the user to make the correction. So that again, for example, is when the user enters numerator and denominator, by mistake he entered 0 as a denominator. So now the exception has been thrown. The catch or except block, it looks at the exception and it gives a proper message, and we can again allow the user to enter the denominator, so that this time he corrects the mistake, he enters a non-zero denominator, so that he will get the proper output. Okay, or when he enters again, he is inputting his string. Okay, it should be in a string format, so we can allow him to enter it again, so that instead of ABC enters 45 or 65 or whatever it is, which could be converted into integer. Okay, so these kind of abnormal situations can be handled by only exception scenarios. So we'll have a try block. So try block will have all the statements which harbors the statements causing the errors, and the except block will be dealing with giving the error message and allow the person to recover from the exceptional cases. And finally is a block which will be executed at any cost, whether the program is abnormal execution or normal execution, whatever it is. Finally is used for releasing the memory resources and all. Okay, so all these things we'll discuss in our demonstration. Right? So let me just go to my Anaconda Navigator. Okay, I just save it. I'll go to my Anaconda Navigator. So I can see here it's a clean slate. Now let me start with the zero division by zero. Okay, fine. Now let me just say try try. So everything should be in a try catch block. So what I'll do, I'll just say I want to enter two numbers, numerator denominator. We call num is equal to int of input, enter the numerator. Okay. So he is supposed to enter numerator value. Then I'll just copy and paste for denominator. Let me call as denom. Okay. Enter the denominator. Fine. Denominator. Then we'll get the result is equal to num numerator divided by denominator. Then we just print the result is. So we can have formatted output also. I'll just say the result is I can put formatted output dot format, okay, res, so that this res will be substituted for this zero. Okay, fine. Now, so this is try block. I should have except block, except. Okay, then I will have value error, not value error, zero division error. Okay, fine. I'll just say print a denominator cannot be empty. Okay, I think we don't need finally right now. We'll just keep this. Okay, I'll just run it. Enter the numerator, give 10, denominator is 0. See, denominator cannot be empty. Now what happened? Look at this. If I had not given this try catch block, let us see what happens. Look at this. Let me comment this. Okay, let me comment this. I'll try to, I'll just comment this also. Okay, fine. Now I just run it. Okay, indentation problem is there. Yes. Okay, look at this. Numerator 10, 0. Okay, look at this. This is called disgraceful exit. Look at this. This is called disgraceful division, zero division error. ZDE, division by 0. So this is called disgraceful, okay, exit. Okay, disgraceful exit. Now, if you just compare with the previous case, look at this. I'll just uncomment this. I just uncomment this. Look at this. Again, I'll run it. 10, 0. See, now we did not get the answer, but we had a graceful exit. Okay. So you see, there was no errors thrown at the bottom, but it says denominator cannot be empty. So that you can, if you want, you can just continue with the program and you can correct the mistake. How do you do it? So just go here. I'll just say while true. Okay, I just make the indentation again. Look at this. Fine. So while true. So this continues. Which one continues? This try block. Yes, I can say denominator cannot be empty. Try again. I'll say try again. Of course, even if you don't give it, it will just go up and check it. Look at this. Now what I'll do? 10, 0. Look at this. It goes up again. Look at this. Denominator cannot be empty. Enter the numerator. Of course, we could have directly done denominator, no problem. So I'll just say 10, 10. So we got the answer. Result is 1.0. And of course, we should have break out of the loop. Look at this. I'll just say, I'll stop this. Break. Okay. Now I'll run again so that the things are clear. See, I'll just numerator 100, denominator 0. So denominator cannot be empty. See, except, see, this is the error thrown actually. This is the value thrown actually. This is the value thrown. Zero division error. Okay. Basically, it's a class. And you can see here, we get a message denominator cannot be empty. And it continues. It continues to get, it gives one more chance to the user so that he can correct his mistake. So I'll just say 100, 10. The result is 10. That's it. The program has, okay, completed its execution. Okay. How do you know that? if you want, you can just come here and say finally. Okay, finally. Of course, you can do in finally also that the break statement, break, so that you can be sure that it exits proper exit is that. I'll just see, look at this. Run it again. 100, 50, denominator 50. Result is 2.0. Look at this. It has come out. It has come to finally and it has broken. It is not continuing again. Okay. So this is how you handle exceptions. See, this is a statement. See, the try block must contain the statements which may cause some runtime error. So when the denominator is 0, see what happens when the denominator is 0, the result will be see, it will try to put infinity inside RES. Infinity cannot be stored in any variable. So what happens? It never goes here. The moment the exception is thrown, it comes to catch block. It comes to except block. Inside except block, if this is thrown, if this is the message, then what you can just denominator cannot be empty. Okay, fine, and it gives a message, and again, as we put everything in while loop, it goes up again. It goes up again, and it takes a numerator, denominator again. Okay, the process repeats. Okay. Now this exception, apart from this, I can have one more exception. Look at this. Except I can just say value error. What is this? I'll just say copy this and paste it here. Print. I'll just say number format is wrong. Number format is wrong. Okay. Now what happens is, look at this. What is this? Suppose for numerator I am entering 55, whatever it is. For denominator, instead of entering some number, I am entering ABCD. So in this case, this value error will be thrown, and it will give the message number format is wrong. Okay, let me give you an example. This I am just giving. Okay, 55 ABC. See, number format is wrong. Number format is wrong. Now what happens is, okay, now again it should go back and give me the things. Okay, let me just check it. Denominator cannot be empty. Print number format is wrong. I think it should give me again one more chance to enter. We'll see what happened. I think finally got. Oh, we put break inside this. So what I'll just remove this. See, of course, the problem arises. Okay, I'll put break here. Break. Okay. Fine. Finally, I won't break. I'll just say finally. Okay, I'll just say print. Try again. Try. Okay. So look at this. What was causing when it came to finally? See, finally will be executed whether the abnormal exit is there or graceful exit is there, disgraceful exit. It doesn't matter. It will just come to finally. Now you see number format. I'll just say 55 ABC. Look at this again. Numerator. I'll just say 55. This time I'll say 5. Yeah. Result is 1.0. It comes to try again later, but of course it has come out of the program. It doesn't matter. Okay, it's not continuing anymore. Right? So you can see here. So this try. Okay, now in this situation, now this try did not cause denominator by 0 error. It caused value error. That is the reason you got that message. Look at this. Okay, number format is wrong. So this is a message we are given. So value error was thrown. Okay, it was not 0 division by error. It was value error which was thrown. So it gave me a message number format is wrong. As we put everything in a while loop, again it goes up, and when I give proper format, it gives me answer. It breaks out. See what happens if I gave 55 here, 11 here, 55 by 11 I got 11.0. Sorry, 55 by 5 I got 11.0. The result was displayed. Then it breaks. That's it. Okay, so you should print the result, then break properly. That's called successful completion of the program. If the program has not successfully completed the output, completed the program, you won't get output. But there are two situations. One is disgraceful exit. Other thing is graceful exit. When you say disgraceful exit, you will get a lot of messages at the bottom. Okay, all different kind of messages, and saying that something wrong, everything. And if you have a graceful exit, you will beautifully come out of the program, but without seeing the output. That's the difference. Okay. So try and catch block, it ensures that even if the program does not generate proper output, you have a graceful exit out of the program. This is the point. Okay. And of course, we can have one more error called, except, that's called, file error. Okay. IO error. IO error. These are all different types of errors. Of course, I think this time there will be no file error. I just copy this and say, okay, file cannot be opened, something like that. Cannot be opened. Okay. Now, of course, this error will not be thrown because we have no files at all. So look at this. I'll just show you that. I'll run it. It comes to numerator. I just say 100. Okay, I'll just say 20. You can see a result is 5.0. That's it. This try again comes because of the finally. That's it. Okay. And of course, if I try to open a file, in that case, I'll just comment these two, all three statements, and I'll say fp is equal to open. Okay. I'll say d colon / python. I'll say python.txt. This file is not there. In fact, I'm just trying to give a file which is not there. Okay. Then, okay, I just say fp dot data is equal to fp dot read. And of course, I'll fp read and just print data. Okay. Now what happens is you can just see that file cannot be opened here. Look at this. Okay, I save it. In fact, I just run it, not save it. Okay, I just run it. The file cannot be opened. Try again. Okay. So see, because this here we have no input, so it's keep on continuing. That's all. That's the difference actually. Okay. So I just clear it. Okay. I just give a message and break out of it. Look at this. File cannot be, just break. Okay, so look at this. I just run it again. You can see at the bottom, file cannot be opened. Try again because the file is not there. Just I randomly type some name. Suppose if I say marks underscore stud. Okay, now you can see here. Just come down. I think this file is there. Yeah, I got the file open. Look at this. The file got opened. Of course, I don't need this message. I'll just remove it. Okay, it's quite awkward. I'll just say see. I remove this. Yeah, we opened the file because the file is existing. Marks.stud is existing, so the file got opened and printed the data. Suppose if I give python.txt, which is nowhere existing, the python.txt, my python.txt, no file are with that name. So if I just come down, okay, look at this, file cannot be opened. Okay, fine. Suppose if this message is not there, for example, if this try catch is not there, you will get a lot of awkward message at the bottom. The program will terminate in between. Okay, so that should not happen. So no program should have a disgraceful exit. Okay, that is why we use try and catch block, try and except block. Okay, hope thing was clear. We'll continue with our next discussion in some other interesting demonstration. Thank you.